Hey, what up, everybody? It's Jolly back again on this beautiful sunny day. Not to talk about the weather, which has been nice, but to talk about baby calculus with you guys. You guys, we made it over the hump of using the limit definition of derivatives, which is kind of awful and painful and long and tedious. Today is where it starts to get a lot better. We're still not going to talk about what concepts are coming up, but really it's just kind of today's building up another tool that you need for derivatives before we kind of bring it all together. So, you guys, today is all about the power rule. So this is the power rule of derivatives, and I'll explain what that means in a second. Last video, I showed you guys that if you have a function, x squared, that the derivative of that function is 2x. I think we did that by the whole, x feeding x plus h into itself and subtracting and using the whole limit definition. It was a whole big thing. If you had done the limit definition with a different function, like, let's say it was x cubed, the derivative of that function would be 3x squared. If we had done, let's say, x to the fourth, then the derivative would have been 4x cubed. Are you guys seeing a pattern emerging? For instance, could you guys predict what the derivative is going to be of x to the fifth? Anybody? Raise your hand. Oh, yes, you in the back. Johnny, what's that? Yes, that is correct, Johnny. It is 5x to the fourth. Are you guys seeing the pattern? Here's the pattern, if you don't see it. On this first one here, it was a power of 2. Now, what you need to picture is that that 2 is going to come out in front of the x, and then the whole power of 2 drops down by 1. So this is really like x to the 1 power here, even though we don't write that. On the next one, if you picture that 3 coming out front, and then this 3 dropping down by 1, you would get 3x squared. Here, if you take the 4, drop it out front, and then bring the 4 out front and then drop the 4 down by 1, you would get 4x cubed. Same thing with the 5. I call it the old pop and drop because you pop it out front and then you drop it down 1. So from the pop and drop, you get 5x to the fourth. The general rule for this, I guess we'll just call it the general power rule, is if you have a function f of x is equal to ax to the n, that this becomes, that's an arrow, sorry for my handwriting, the derivative of this would be, bring the n out in front, it gets multiplied with the a, so I guess we'll call this a n x to the n minus 1. So let's highlight that with purple. This is the power rule. Yeah, important. You guys, the power rule is awesome because we don't have to use that long, boring definition to find derivatives anymore. In fact, if you have a function that's in the form of something x to the something, finding the derivative is really super simple. Let me do some examples for you guys using the power rule. A lot of time they're going to ask you to find derivatives, but there's like 9 different ways to say find a derivative. The first one that people ask about is the word differentiate. That's just a fancy way to say find the derivative. So if we're going to differentiate, f of x equals 6x cubed plus 10x squared minus 3x plus 7. All you have to do is run the power rule on these little algebra chunklets that are happening here. Can't believe you just laughed because I said chunklet. Very immature. You guys, this first algebra chunklet is 6x cubed. The second one is 10x squared. The third one is negative 3x. And then the last one is positive 7. So with each of those, use a different color here, you would just take the power Piper, no whining while I'm making a math video. You're making me look bad. You pop it out in front and then drop it down by 1. So, f prime of x. The power rule was 6x cubed. The 3 would come out in front and multiply with the 6, so you would get 18x squared because the power came out in front and then dropped down by 1. Same thing with the 10x squared. You pop it and drop it, so the 2 gets multiplied with 10, and you get 20, and then it drops down to the power of 1. But you don't write x to the power of 1, you just leave it as implied that it's 1. Now this guy is interesting, this one right here, because this is a power of 1, and if you were to take the power of 1 and bring it out in front and multiply, it doesn't really change it. But then when you drop the 1 down by a power, it drops down to the 0 power, and something to the 0 power is not 0, but it's just 1. So this becomes -3. Now, this last part here, the +7, I can show you guys the algebra behind it, but really all you need to know is that if you try to take the derivative of a constant, it's just 0. So you don't actually have to do anything with the 7. It's just, you're done right here. This is the derivative of 6x cubed plus 10x squared minus 3x plus 7. Now you might look at that and be like, well, okay, cool, but what even is that? I don't know what I just did. That's totally fine. That's not part of today's lesson. Next class, we're going to bring more things together. Right now, we're just kind of building up these little tools, and then we'll get to like the big picture eventually. My goal today is that you guys can just find derivatives using the power rule. Let's do another quick one. Let's find the derivative of f of x is equal to 3x squared minus 4x to the -3. Oh my gosh, a negative exponent? What do we do? You guys, first of all, don't freak out if it's a negative exponent. God, I'm gonna have to clean that up. Sorry. 3x squared. You guys, we just have to use the power rule on these 3 chunks right here. This guy, and this guy, we can apply 3 different power rules to. So, if I'm going to find in purple, f prime of x, 2 comes out in front, multiplies with the 3, so you get 6x. Remember, the 2 drops down to a 1, but you don't write the 1. Now, a -3 coming out in front with the -4, this would be a positive 12x. But then -3, when you drop it down 1, becomes more negative. So this would be x to the -4th. Now, the +1 on the end, remember, if you have a constant number, like it doesn't have any x attached to it, you can just get rid of it. And that means this is your derivative right here. 6x plus 12x to the -4th. And we're good to go. The last thing I want to show you is something called the second derivative. The way you can write this, here, let's just say this example is find f prime prime of x. So that's like the second derivative. We'll say when f of x is equal to, oh nice, I'm glad they did this example, 10x minus 4 over x squared plus 2. Now, first of all, to find a second derivative, that means that you're just going to take the derivative once, and then whatever you get from there, you just take the derivative of that. The second derivative is the derivative of the derivative. The thing that's a bummer about this problem is this right here, that this is not in the right form. The classic mistake I'll see from students is they'll try to run a power rule like just in the denominator right here, like they'll bring the 2 out in front, but you can't do that. What you have to do is move this back upstairs and make it a negative exponent. So before you take the derivative, you have to rewrite the function as this. 10x minus 4x to the -2 plus 2. Do you guys see how it used to be x squared in the denominator, but then you can move it back up into the numerator, but you have to make the exponent negative. So negative exponent right there, that's important. Now that it's in the form, this whole thing right here is in the form something x to the something, that's when it's appropriate to use the power rule. So let's go ahead and run our power rule. F prime of x is equal to 10x would just be 10 because the 1 comes out in front and then drops it down to a 0, so the x just kind of goes away. Then negative 2 out in front makes that a plus 8x to the negative 3, and the plus 2 on the end just goes away. Now, that's our first derivative. Now we got to take a derivative of that. So run the power rule on it again. This guy is just going to go away because it's just a constant, it's just a number. So really we're just taking the derivative of this part. So the negative 3 comes out in front and multiplies to become negative 24. So it's negative 24x to the negative 4th. And that is your final answer. You guys, that's really about it. I think there's some problems where they ask you to like feed in certain numbers. Like I think with this example, they could say like, find f double prime of negative 1. And that would mean that you just put negative 1 into the function. But negative 1 to the negative 4th is just a positive 1. So this would be negative 24. You could certainly do that with your graphing calculator. I'm not taking your graphing calculator away for the rest of the year, so feel free, go nuts. You guys, Wednesday, I think, is when we will start putting things together and talk about like some big concepts. Yeah, we've laid enough groundwork that we can actually like get into the good stuff of calculus. So Wednesday will be a big one for us and an important one. I hope you guys are doing well.